So there are many different technologies in software. There's too many to count, and everyone is an expert at something different. And the good part about technology is that there's always something new. So even when I started coding 5 years ago, like Ruby was the only like software engineering program that was a language that was object oriented that people used. Python was kind of around, but not really. And within 5 years, we've seen Ruby take a huge nosedive. And unfortunate for me, but that's just kind of how the industry works. So whatever we're learning here might be around in 5 years and might not be around in 5 years. Probably JavaScript will be around forever, but Python may not be the new hotness. It might be replaced by Go. It might be replaced by Elixir. Who knows? But at the end of the day, no matter what, we're always going to have SQL, because no matter what technology you end up using on the front or the back end, you still need to save the data to some sort of database. Now, we've kind of been doing this so far. We've done, I think on Monday or Tuesday, we did stuff with CSV, and we were just writing stuff to a file. And that's totally okay. There's nothing wrong with that. But we want to store a lot of data inside of a database. And the way that we do that is using SQL, or structured query language. That's where we're going to talk about today. So RDBMS is a gross acronym, but it stands for Relational Database Management System. There's two halves to this. So when we're talking about SQL, sidebar. The good part about SQL is that it's basically starting from scratch. So if you really struggled with algorithms and languages and stuff like that, think of SQL as a brand new start, because everyone's coming at the same playing field. It's very, very structured, and it's not loosely typed, meaning that like Python, you can declare one variable equal to something and then immediately overwrite that variable, and then you might be able to get away with some indentation that's 2 spaces and then some that's 4. When it comes to SQL, it's either going to work or it's not. That's the good part about it. It's either going to sorry, parents' house, it's either going to really work out or it's not going to work out. And that's the good part. So if you haven't felt terribly encouraged by everything so far, think of SQL as a kind of a new starting point for everybody. So there's 2 halves to relational database management systems. One of them is how you store your stuff. And you're going to store your stuff very much like, I don't know how to explain it. It's kind of like a spreadsheet. You're going to have tables, you're going to have columns and rows. That's the most simple way to understand it. And then there's a way to get that particular stuff using the query mechanism, which is SQL. So when we talk about storage and data storage, what you have to figure out, how am I going to store that data? Like, in what organized way can I store it? And then how do I get stuff out of it? So this is what a database table kind of looks like. It's a visual representation of what a database table looks like. We have students, we have these columns right over here, and we have individual rows. So again, the table name is this right up top. We've got the columns, and then we've got the rows, each individual record. This looks very much like a spreadsheet. The whole thing, the whole combination of columns and rows put together gives you your table. The columns are the vertical ones, and the rows are your horizontal ones. I feel like this is fairly straightforward. Any questions so far? Okay. When we talk about a schema, we think of it as a representation of a plan. So imagine you're trying to start a website. This is actually a fairly common interview question. Let's say that you want to start a website for, selling, I don't know, creating recipes on like a recipe2.0.com. So if you're creating recipes, what are some of the tables that you're going to need? And when we say tables, we're primarily focused on like, what are the nouns that are associated with this particular website. So if you think about Amazon, the schema that they might have is like, what kind of nouns are they using? So is it, they've got users, that might be a table inside of Amazon. They have items that they're selling. They might have categories that they're selling from. They might have deals. Like, these are examples of, tables that you might have inside of your database. if we think about like code platoon, what we're thinking about is like, what are we, if we were to create a database for code platoon day to day, it's fairly simple. It's just students. That's all. That's probably all the things that we need. And students as a table have probably a few columns like first name, last name, branch of service, date of birth, you know, and other things like that. So we've got that table name, we got column names and column types. Let's take a look at another one. Actually, no, let's just go to tables. So when we create a table, it's fairly straightforward. It's just a bunch of commands that you must enter in this particular order. So the tables are going to be identified by a particular name. So the way that I create a database table on my computer is I would type in create table and then the name of the table. And you'll notice, like we saw a little bit earlier, that all the table names are going to be plural. The reason behind that is because this particular table, students, include many individual student rows. So again, students, because there are a lot of individual student rows. Yep, any name is valid, but you want to follow this convention. It's going to be lowercase, and it's going to all be plural nouns. So if I wanted to store people, purchase orders, or likes on a particular post, the table name would be the pluralized lowercase snake case version of that. So think about your Python variables. So if you're storing a lot of people, it would be a persons table or a users table. If you wanted to store purchase orders, it's just pretty easy, just purchase underscore orders. These are all lowercase, snake cased, and plural. So if I wanted to have, I don't know, books, like if I wanted to store a bunch of books, it would just be lowercase books as a table name. The columns are a little bit different. So we've got this is an example of a SQL query. It's pretty straightforward in the sense that you can read it and have a general idea of what's going on. So every single column is going to have a name, and they're going to have certain data types. We'll talk about the column names first. So we want all of these to be lowercase, singular nouns or adjectives to describe what kind of data that you're storing. So I'm going to create a table called students. And inside the students table, there are going to be 4 columns: the ID, the first name, the last name, and whether or not they're on probation. So this is these bolded portions right over here, the ID, first name, last name, and on probation. Those are the column names that we've got. Pretty simple. Create table students, ID, first name, last name, and on probation. When it comes to column types, it's basically what kind of data are you trying to hold inside of this particular column. So I've got create table students, same thing. I'm creating a table in my database called students. They have 4 attributes, or 4 column names: ID, first name, last name, and on probation. And this is the type of data that they're going to store inside of there. The ID is always going to be an integer. The first name is always going to be a varchar 255. Last name will be a varchar 255. And on probation is going to be a boolean. Varchar 255 is just a fancy way of saying a string that's up to 255 characters long. So I'm going to store a number here. I'm going to store a string up to 255 characters, another string up to 255 characters, and then on probation is just going to be a true or false value. There are different. Sorry, I see a hand. Go ahead.
Is there a reason that it's 255?
Sure. Good question. So the question was, is there a reason why it's 255? You can make this as short or as long as you wish. Generally speaking, once you pass 255 characters, it's going to be a paragraph. So you'd create this as a text data column type. But if you're going to store something real short, like email address, first name, last name, maybe date of birth, something that's short and that you know, like finitely how long it's going to be, you can just go ahead and put that number inside of here. I just generally put 255 in the case that someone's name is actually 255 characters. But if you know that most people's names are only going to be at most 10 characters, 15 characters long, you can go ahead and just hard code it so that you can't put in extra stuff. Now there's going to be different types of SQL database like flavors. So you can kind of think of SQL as ice cream. So ice cream is just a generic way of saying like a generic dessert. But there are different flavors of that dessert, right? There's vanilla, there's chocolate, there's strawberry, and everything else. Similarly, when we talk about when we talk about SQL databases, there's SQL database is the kind of database, but there's different flavors of it. Every company is going to work with something different. So some companies work with Postgres as with SQL. Some people work with MySQL. Some people work with MS SQL. Some people work with Oracle. If you ever work with Oracle, I would run. We're going to be working on Postgres because that's what most of the industry is using. It's an open source flavor of SQL database. These are common types between, you know, Postgres, MySQL, MS SQL, Oracle, all these different types of SQL databases. These are very, very common. So we've got integers. Those are just numbers ranging from -2 to the 31st to 2 to the 31st. So it's basically any number. Decimal is a fractional. Varchar is basically strings from length 1 to 255. Text is longer strings than 255 characters. We got date, and we got timestamp. These are examples of column types that are fairly, that are shared. I'm going to pause for a question. No? Yep, go ahead.
I know you said there's some types of those are some types of data types. Are there many more?
All right, so I didn't hear you quite clearly. So you said these are some of the types of databases. Are there more?
Yeah, are there more?
There's a lot more. Yeah. So there's a lot more in terms of just like flavors of SQL, but they're so similar that once you know one of these really well, you know the others pretty well. So
In terms of the data types.
Are there more data types?
oh, are there more data types? Yes, there are more data types, but these are the common ones. Think about what you would want to store inside of a database. Most of the time, it's just numbers and timestamps and booleans and text. Like if you ever signed up for a form, like the internet is a giant form. If you realize when you sign in, you log in with your email and your password. That's a giant form. When you place an order, it's a giant form, but it's just it looks a little bit different. At the end of the day, everything is about data, and these are pretty much the most common ones. And there are more data types, but you're not going to use them quite often. When you start designing your schemas with some of the challenges over the weekend, you're going to have the good part about software engineering is that you can build something from complete scratch, meaning that before anything happens, you can think about the database and the type of data that you want to store inside of there. You're never going to have more freedom than at the very, very beginning. So if you're thinking about, you know, how do I create a program for Code Platoon that keeps track of attendance? Like you can think of all the different tables that you might need, maybe a students table, maybe attendance records table, maybe you can think about whatever you want. But eventually you're going to need to create new classes. You're going to need to write new methods. You're going to need to refactor the existing code that you have. Think of something like Jeff Bezos back in the day. So I use like Jeff Bezos before and after. I enjoy this one because, I mean, this is Jeff Bezos back in 1998 when he first started creating Amazon. If you've ever seen that picture of him, Jeff Bezos, Amazon, desk. This is Jeff Bezos in 1999 before he became like one of the richest men in the entire world. Like he's just working in a regular office with Amazon.com, like serial killer painted on his wall right over here. When he first started, the schema, the database table that he had for Amazon.com was just books, orders, and users. That's it. Probably just 3 tables. That's all that Amazon sold. And then if you take a look at him today, he's obviously much more buff and, you know, has the tech bro vest and everything like that. But like things have changed over the course of time. He had to make modifications to his particular schema. He's not just selling books and worrying about users and orders and books. He has to worry about things like all different items. He's a third-party marketplace. He's got video. He's got, you know, drones, and like the thing will eventually evolve. You need to add onto your database as your particular thing evolves. So for this reason, take your time when designing a schema. You want to think about every possible, as much as possible, whatever could happen in the future, you want to prep for that early on rather than reactively. It's never going to be cheaper to make changes to your database before you actually create it or when you alter it, then later down the road. We talk about this quite often, but it also extends over to SQL. You want to do one thing well, meaning that if you have a table that does too many things, you should probably separate that into two tables. If you have classes that do too many things, you should probably separate that into different classes. So let's take a look at this. If we have a particular table inside of here, stored inside of our relational database management system, you'll take a look right here and we'll see that this probably does too many things. So where do you think I could probably just split this down the middle?
Line 1.
Basically, line 1 is something completely different. So we've got, let's say that this is a record of a student inside of a database. What we've got here is we've got Tiana and Elda, and this is the student information probably here right on the left, and then their address on the right. It could, you could argue that this is probably the only table that you need, but you could also separate it into two different tables. One maybe students, one maybe addresses. And the idea here is that what if Tiana has a younger sibling or an older sibling? At that particular point, if you keep it all on one huge table, you're repeating your data twice. And this may seem like very stupid and very small because you're probably a school district, you're only serving 1,000, 2,000 people at a time, so it's not going to impact anything. But all you have to think about is down the road. When it comes to scale, if you're talking about Amazon.com and they have everything on one giant customers table instead of an addresses table, they could be repeating addresses, thousands of times, tens of thousands of times. If they're talking about things like, if I'm ordering for a business and I'm going to deliver to, PayPal San Jose, for instance, and you have, employees 1 through 1,000 all delivering to their work address, that's probably not the most efficient use of your database because every single record costs you money. It's going to end up being like, I only have a maximum amount on my database and then I have to keep increasing and keep increasing and keep increasing. And every time that I search, it's going to take longer and longer and longer. So you want to separate things as early as possible. So you don't want to repeat yourself. So instead of having all of the information on one giant students table, you might have two students' table. But we've got inside the students' addresses, we've got first name and last name, and we also have first name and last name. You don't want to repeat yourself as much as you can. So the one way that we're going to do that is we're going to, actually, yeah, that's a good point to bring up. So we don't want to repeat ourselves because it leaves extra work for us. When I was going through school, a lot of parents got divorced and then they got remarried, and a lot of the kids started to change their names based off of their step-parents' name. So if you have a students table and you have an addresses table, and they both have the first name and last name, and you change the last name on the students table but not the addresses table, when you send out mail, you're going to have the old name. Your data is not completely up to date. So in order to end this kind of duplication, does anyone have any idea how I can associate these two tables together so that I'm not duplicating the same thing twice?
Use the ID from one table for the other table as well?
Yep, that's exactly it. So what we can do here is we have a students table and we have an addresses table. What we're saying here is that this address belongs to one particular student. So if I have separate records, I'm going to have Tiana Lowe, she's not on probation, and the address I'm going to pass off to another table because the other table knows better. So I'm going to say, whenever you want to find the address, go to ID number 4, and that's the person's address. So that all I need to do is update the first name and last name. Students is only in charge of that. And if Tiana ever moves, we can add another address and associate her with that new ID rather than the old one. So this is called belongs to relationship, and an address belongs to a student. Another thing I wanted to point out, and this I've seen this happen in very real life, is that you want to use things like a unique, so when you start entering things, when it comes to column types, you can also add in things like not null or check uniqueness, basically to make sure that your data is always good. So we've got this fella over here. We've got james@example.com. And we also have james@example.com, where we have two sets of passwords. Which password are we going to check whenever James logs in? Any thoughts? The first one, or pretty much whichever one the database chooses to do that particular day. So you want to make sure that before you save things into the database, you want to check that it's unique or it's not unique, especially for things like email addresses. You don't want to duplicate data over and over again. And I've seen this happen in real life with Blue Cross Blue Shield in particular. So I had two health insurance plans, one with an old employer and one with a new employer. They entered me twice inside the database, so whenever I would log in, it would basically be a random selection of whether or not it was my old employer or my new employer, and that should not happen. Another way of solving it would be maybe a user has many health insurance plans. That's pretty much all you needed to do. Or for the Venture Chicago app, I had a student Venture card, and I also had a real Venture card, like a full adult Venture card. And then whenever I log in, it's literally, I would have to log in and out 5 to 10 times in order to get to the right one. And that's because I was saved twice inside the database under two different things. So make sure that you do check your uniqueness as much as possible. Let's talk about this right here. What's going on? Like, is that anyone's password in real life? What do you think happened here? Like, why is it looking like that rather than like password 123?
Is it hash?
It is a hash password. Can you explain what that is for the class?
Basically, when they take the password, they just scramble it. We did something similar with what was it, Caesar's?
Yeah, kind of like Caesar Cipher is too easy, but it's similar to that. Yeah.
Yeah.
Yep.
And then to put that in there so that if the database was to get access, you wouldn't have access to every single person's password.
Yeah, pretty much. So good places, like good companies, will hash your password so that when you save it inside of the database, it looks something like this. Now, you can kind of think of it as like you've got an apple in your hand. It looks one way, and when you chew it and you digest it, it comes out a different way. That different way is what you want to store inside the database rather than the original. Because what happens here is there are certain companies like Target that stored their passwords in plain text. And what that means is it'd be like john@codeplatoon.com and my password would just be out there. It's not hashed, it's not protected in any way. So when the database does get hacked, hackers have a list of a bunch of emails and a bunch of passwords. Now, for most people, it's particularly problematic, and it might be problematic for you because how many websites do you use with the same email and the same password? You don't need to answer that, but just think about that for a second, because I used to do this all the time. I used to have one password for everything. So once they have your target.com password and your email address, they can guess that you have a Chase account, maybe a Bank of America account, maybe an Amazon account, maybe a GameStop account, and they can order a bunch of stuff. Once they have that particular email address, they know for most people that they use the same password over and over again. So you want to always hash your passwords whenever it comes in. Any questions so far? All right, so we talked about the first half of the relational database management system here online on slide number 2. We talked about columns, tables, and rows. So table consists of many columns, and a table consists of many columns and many rows of data. So that's just how I store the data and how I set it up. If I wanted to get the data out of the database, we're going to use something called SQL queries. It's basically a programming language. It's basically the syntax inside of SQL that you need in order to get stuff. So it's pretty simple. It generally follows a certain, it always follows a very definite pattern. The first word that you're always going to have is select, insert, update, or delete. And they're very descriptive on what they do. Select, it's basically saying, get me the rows that match this particular criteria. Insert, pretty simple, I'm putting stuff inside the database. Update, I'm updating something in the database, and delete, I'm deleting something from the database. This is what like a small SQL query looks like. So it's select, so you know that particular word is like a SQL word. I'm going to be getting stuff from the database. Star basically means everything. So select everything from the students table, and that's it. So the good part about SQL is it's very, very straightforward, and it's always going to be consistent. Select everything from students. So before I had Tiana and Elda, so I would get something that looks like this. But if I only wanted a few things instead of the star, I could specify those column names as well. So I could do select ID and first name from students, and I would only get those two things back. Going back one slide, selecting star from students gives me the ID, the first name, and the last name from that table that we created a little bit earlier. Sometimes you only want certain things. Like if I did select ID and first name from users when I was at Groupon, I would get, I don't know, at any time there were like 30 million users, so I get like 30 million results. And I don't want that. I only want the particular student where their ID is number 2. So the way that I would do that is select, there you go again. I'm going to grab something from the database. Specifically, I want to grab the ID and the first name from, you'll notice that these caps ones are basically for all of the those protected SQL words. So select from. So select the ID and the first name from the students table that we created where the ID is equal to 2. So you're trying to parse down the number of things that are going to be returned. We had Tiana and Elda, and I'm just getting Elda, the first name and the ID number, because that's where this matches up. So there's a bunch of conditionals supported by the where clause, and here are a few of them. A lot of it looks like kind of like those conditional operators back in when we were doing stuff with Python. So we've got the equal, we've got the bang equal, between, in, and like, and we'll see a few of these examples right here. So these are some example conditions. So I want to select, so I want to get stuff from the database. I want to get everything from the students table where the first name is equal to Andre. So any student, I want to grab any student with the first name of Andre, I want to get all the information. Select star from enrollments where grade is something A. I don't know what that is. Let's go back. Oh, okay. It's not equal to A. So if you wanted to see all the students in your particular class that didn't have A as a grade, you can just do select star. So select everybody from enrollments where the grade is not equal to A. Maybe I want to select all the classes that my university is offering where the credits are between 3 and 4. Reads pretty simple. So it's the column is between 2 values, so the value that you're looking for is between 3 and 4. If I'm looking for a particular list of grades, so select all the people who are doing well in my class, getting an A or B, selecting everything from this table where the grade is in A or B. So it's either going to be an A or a B. And then finally, this last one is a little bit strange. So can I get someone to explain this? I'm going to go back 1 second. Pay attention to this bottom one right over here. And then can somebody explain this last one?
I'll try.
Okay, go ahead, Holly.
Select everything from the table classes.
Yes.
Where the name has anything with the stream art in it.
Mm-hmm.
And has less or has more than 3 credits.
Yep, that's pretty much it. Yeah, that's perfect. There's one thing I might change, but I'll go over it right now. So we got select everything. So select everything from the classes table where the name like art. So this percentage sign is a wildcard operator. So it's anything that starts with the word ART. So it could be art history, art theory, art anything. It has to start with ART and then anything else. And then the credit is greater than 3. So when I was going through college, I was always looking for the easiest method. So despite going to Northwestern, I took classes like Our Dynamic Planet, where I learned about the Earth's crust, mantle, and core. I was with all the football players in that class. So I would always have something where it's like, select star from classes where grading is easy and credits is greater than, I don't know. So you could always these are examples of conditions that you could run. And if you think of it in a business context, let's take Amazon as a whole business. You want to basically reward the people with the companies that sell the most, or you want to offer a deal to people who haven't bought in a while. So that might be something like select star from users where last purchase is greater than 6 months ago, or greater than the date of 6 months ago.
I have a question on that wildcard operator. Said that means that it's only going to return words that start, or columns that or whatever starts with that word.
Yes.
So not if it's just in it anywhere. So if you had history of art, it wouldn't find it.
So the way that this one works, we've got where name is like this. So there's going to be a column called name. There's going to be a bunch of values inside of there. As long as it starts with the letters ART in this order, and with anything else, it's going to catch. So if you do history art, it won't catch because you're looking for history followed by the word art. If you're looking for art followed by the word history, that will show up because you're looking for ART and then anything.
If you put the percentage in front of art.
Yeah, what happens when I put the percentage in front of art? I can't change the slide right now, but if I were to put this percentage in front of art, it would just be anything with select everything from classes where the name has anything in the front, the word art in the middle, and anything at the end. So you could do history art, Romanian art, French art, that would also work. French art history would also work. But if I were looking for French art history with this current one, it wouldn't work because I'm looking for the word. I mean, it actually might work. It might work. I don't think it will, though.
Understood. Thank you.
All right, so that's the select statement. The select is to get stuff out. 90% of the time, you're talking about select statements, but oftentimes you need to insert data. So if I want to insert into data, it follows a very specific formula. The way that this one works is I have insert into the table name, and then opening and closing parentheses, the 3 columns in that particular order. First name, last name, and birth date. And then you type in the word values, and then in order, first name, last name, birth date. It's pretty straightforward. So insert into this particular table a new row. A new row is going to have first name, last name, birthday in this order. Michelle DuPont, 1982 to 11. Update is something similar. So I'm going to update addresses. So I have a record already with ID number 2. I'm going to update this table. I'm going to set line 1 equal to something different and zip code equal to something different where the ID is equal to 2. So essentially what this is doing is saying, go inside the addresses database. Go inside the address table, find ID number 2, and update line 1 to 200 Church Street and zip code to 60010. Now, and same thing over here with delete. Delete from addresses where ID is number equal to 2. So delete the second record inside of the addresses table. Now, it's really important to have conditions when you're updating and when you're deleting. So select and insert are fairly simple. I feel like those are straightforward. Update and delete are a little bit more tricky. You always want to make sure that you have a condition when you do delete. Because otherwise, if I say update addresses, set line 1 equal to 200 Church Street and zip code equal to this, and I don't have where ID is equal to 2, every single person in my entire database is going to move to that address. And if I delete all the addresses without instructing which one to delete, if I just say delete from addresses and I don't have where ID equals 2, you've just deleted your entire database and you just got fired. Let's see, are there any other slides? No. So this is a little bit of a primer on SQL. It's not, obviously we're not typing anything out quite yet. Let's take a look at the curriculum. So I just wanted you to have some sort of a semblance of an understanding on SQL prior to our thing on Tuesday. Today, what we're going to do is we're going to be working in our pairs, and we're going to just work on OO stuff. That's all that we're going to be doing. Over the weekend, with regards to SQL, you're going to be reading Intro to Persistence, which I wrote a long time ago. But essentially, it's basically why, it's a written version of everything that I just said. Why should we be using a database? How do we use a database? and just a little bit of history as well. On Monday, when we're not in class, I want you to start working on this right over here. So 6-3. Oh, wow, is Monday 6-3 already? Yes. No, Monday's not 6-3. I'm on the wrong week. So there's no class on Monday, but you're going to read Intro to Persistence. Here are the slides, and you can go back to this video a little bit later. But there's a lot of challenges, and I just want you to kind of do them in order. They're going to walk you through how to do things with SQL. How do I design a database? How do I run SQL queries on that database? So we got SQL basics here. You're going to create a database called school. You're going to create a bunch of students right over here. You're going to insert students. You're going to select things from them, and you're also going to delete them. So this will walk you through how to actually run SQL on your particular machine. Then you're going to talk about schema design. So how do I design a database? Again, a lot of the same things from the slides right over here, so you don't need to always jump back and forth. But in the case that I ever wanted to like do Grubhub, this might be a few of the tables that I have on Grubhub or Blue Apron or Instagram. And your goal is to figure out how are these related, and how do I associate an order with a restaurant? Does a restaurant belong to an order? Does an order belong to a restaurant? How do I associate those together? And then we will go over that on Wednesday. And you can kind of see there's just a whole bunch of different challenges. Some of them are going to be ones that I wrote, and then 2 of them are going to be ones that are just online, but it's just good to have. So some simple SQL basics. So let's just show this over here. If I wanted to, this is a little small. Let's say I've got a database called world, and these are the column names, and I want to show the population of France. I know I'm going to need a select statement. I know I want to show the population of Germany, so I just want to select the population from the world table where the name is equal to Germany. I submit that one, and it'll tell me whether or not I'm right or wrong with this ugly face over here. So it's just a good way to practice this SQL. All right, let's take, are there any questions? I went a little quick. All right. Again, SQL is one of those things where no matter what you do, it's always going to come down to data persistence, which means just like the stuff that you save is going to be saved inside of a database. In order to interact with it, you have to know SQL. So you can be doing JavaScript on the front end, you can be doing Python on the back end, you could be doing C++, it doesn't matter. At the end of the day, everything comes down to SQL. So we are going to spend an entire week on SQL, and yeah, it should be a lot of fun. It's a good point to, I'll get to you. It's a good restart point for a lot of people if you have been struggling so far. I had that question from somebody on my right side.
Is there any like undo method, or like, you know how we have Command Z, blah, blah, blah. There's none of that in SQL, so you really get fired if you fuck up that data.
Yeah. So there is no undo method. So if you insert something that you shouldn't have, you can just go ahead and find it and delete it. That's totally okay. If you drop the whole database, like obviously there should be guards against that. So there's going to be ways for your boss to basically prevent you from doing stuff like that. But in the case that you have like master access at all times, you could delete the whole database and there's no undo. Yeah. It's pretty dangerous. All right, let's take 6. Yeah, go ahead. Christian. Christian?
Never mind.
Okay, let's take 6 minutes. We're going to come back and we're going to have Gina do our Beyond Tech.